That's like the most useful resource that you can possibly find on practical AI today. Kaggle is a great place to get started. Even if you're a beginner, there's a place for you. Here are the 8 major steps to create this kernel at Kaggle. But first, let me introduce Kaggle to you. Here we are in the Kaggle website. You can sign in with Google, Facebook, or create your own account. You can go to the competitions. In this tutorial, we are going to be using the Humpback Whale Identification Challenge. Can you identify a whale by its tail? This is the proposal of the competition. You can have a look at the description here, the timeline, the prizes. Then you can have a look at the data. You can download this when you sign in. You can start your new kernel here, or you can follow up mine down here. First things first, we need to define what tools we are going to be using. Python and R are the most common ways to go. In this tutorial, we are going to be using Python alongside PyTorch. If you want me to make more videos on TensorFlow, Scikit, or Keras, just subscribe and leave the comment below. Here are the most important libraries we need to work with this kernel. We need NumPy to make the vector and matrices calculations, Pandas to work with the datasets, Matplotlib, OpenCV, and Pil to work with the images, and OS to work with the files. We can execute this block of code with Ctrl-Enter. The OS library will enable us to store the global paths of each of the train, test, and train.csv files. We can see this here. We can print what files we have on our directory and print the CSV train path. We can see here that is Kaggle input train.csv. So we have defined what tools we are going to be using. This is the step we are going to be looking inside the dataset. Okay, Pandas is the way to go when you need to work with datasets. See how easy it is to load the dataset into memory. We just use pd.read_csv and pass the CSV train path. We can have a look then what is inside of the dataset with df.head. We see here that we have the image names and the image labels. But these are whales, right? You want to see them. How do you do that? It's time to make visualizations. We have an image dataset here, but this can easily apply to text datasets because you can make word clouds, we can make word frequency plots. So if you want me to make more videos on text analysis, you just subscribe on the button below and leave a comment with I love the text analysis. To ease up this process, we can have a new column called image path. That is, this column will store the global path of the files. We can have a look here with df.head. Now we have the full path of the images. Let the fun begin. I'm suspect to speak here because I love data visualization. So let me explain some things to you first. We have this function here, np.random.choice. What does this do? We can execute this here and pass some array and choose 2 values. So what does this do? It gets an array as an argument and then how much random values. So what we are doing, we are taking the whole image set or we just want 5 whales. And then we also have a for inline loop. How does it work? We have I for I in range of 10. This works as a for loop, but in just one line. Okay, now we can move on. We have here 5 random whales. Actually I changed the code here to image path because as we have created our image path, we don't need to add the full path to the variable. So we need just this line. So what we have here is 5 random whales to plot. We can see that we run this again, we will have another different images. So how to make this plot? We can use matplotlib. We can make a for loop and get the full path random whales, open the image, and then use plt.imageShow and show the image. Then use plt.show. We can see the 5 random whales here. Okay, but we see that these are all different sizes and all different types. To feed our neural network, we need regular sizes and we need just grayscale images. For this simple model, more advanced models like convolutional neural networks can accept RGB images. This is a huge part of any data science project. A week ago or so, I was playing around with MNIST and I could see a huge difference when I did the normalization and I did not the normalization. I'm going to show you 2 simple ways you can make that. Okay, before I show you the 2 ways, we have here some resources that are quite useful. We can import now Torch Vision and test it some functionalities. We have here OpenCV as CV2. We can read our images, pass it to grayscale and then resize it. Then we can show this image. We can see here the result. With Torch Vision, we can transform to grayscale, resize, crop, transform to tensor, and then normalize. And we can see the results. We have the shape of the image and then the actual result. Now we know the basics of pre-processing the data. And what about cleaning it up? Cleaning is a big challenge in AI. Some even say that 80% of the project you spend up cleaning and pre-processing your data and 20% building your model. So, how can we make this on pandas? Now you can clean this dataset up. If we see how many of each label we have, you can see that there's a huge difference between the new whale and the others. So this is probably cause overfitting. To simplify this tutorial, we are going to be excluding the new whale from the dataset. So we can do this with pandas. We get a feature, we get an array with the true or false, if the df ID is or isn't a new whale, and then we pass it to the df. And then we can see that we have our dataset without the new whale in it. There are many ways you can make encoding on your project. One-hot encoding is the most common one, but we are going to take a simple approach. We are going to transform text into numbers. To make the encoding, we can use pd.unique. I can show you what this does. We can use pd.unique here, and then we can see that it shows the unique labels that we have in our dataset. If you do this, we will have a number for each unique label in our dataset. What we will be doing is replacing the number for the label. And you can see now our new dataset. We can see that it has replaced the text for a specific number. To handle the dataset, we are going to be taking a simple approach. We are going to just take the first 1,000 images. And then we are going to be taking also the first 1,000 labels. And this is it. But by the end of this video, I'm going to be sharing with you a free resource that uses a much more elegant approach. To handle the dataset, we're going to be importing the torch and all its functions. Then we are going to be taking the first 1,000 images and using the preprocess to preprocess them. Now we have all we need to create our own neural network. Here we are going to be using a MLP, that stands for multi-layer perceptron. We could create our own CNN, but we're going to start simple. But by the end of this video, I'm going to be sharing this resource that does exactly that. How could you create a neural network yourself? If you are new to the field, I've put some resources that could help you. You can find it here. But I know, we are all busy people and don't have that much time to go through all the blogs. So I will explain that here to you how we are going to be building a simple neural network. This neural network doesn't accept a full image. It just accepts a flattened vector. But how does this work? We have an example here for a 2x2 image, and then it is transformed into a flattened vector. This vector is then fed to the neural network. We do the forward pass. The outcome then will pop. Here you can see that we have cat, dog, turtle and birds. And then this neural network is showing us that this is a turtle. But wait, this is actually a dog. Now what? Calm down, there's still hope. We can do what's called backpropagation. We will calculate our loss based on how far the outcome is away from the actual output and update the weights and biases in that way. But how can we code this? Here we have a very simple linear model. We have 128 by 128 image input, so it's the same here. We have a 2x2 and then we need 4 neurons to make this work. Here we have 122 by 122 because our image is that size. Then we have how many outputs is going to take, and then this is replicated to the other linear layer after the sigmoid, and then we cut this by 2 and the next output is 128. Then we use in sigmoid again, and the final layer, linear layer, we have 128 and the max label. How this works? We see that our labels were classified as numbers. So if you have 0 to 100 labels, then if the max value of the 1000 image that we get is 100, we need at least 100 neurons to make predictions for every outcome. And then we pass to the logSoftMax function. We are going to be using an optimizer here, a stochastic gradient descent, and a negative likelihood loss. We can see our model here. That is, it all works out. And then that is actually the training part. We have our epochs. That is the number of times we are going to retrain the neural network. We have the batch size. That is, if you have 100 images, then we are going to be using 10 iterations. We are getting batches of 10 images and working the way through. So if you have 1000 images and a batch size of 10, we need 100 iterations to go through all the images. So for each epoch, we are going to be iterating through and getting. Here we are going to be getting the 0 to 10th image, and then it moves on. Here we are going to be flattening our images and then getting our labels. And here are the steps that I talked about. We have to clean our gradient, calculate the output. This is this part here. Then with the output, we calculate how far our predictions are for the actual values. Then we do it the backpropagation and actualization of the weights and biases. Then we add up our loss. We can run up this here and see our loss. This is a huge loss. We want our loss around 0. But okay, this is understandable. Why? Because we used a MLP for a image dataset. We used just the 1000 images, and this gives a lot of space for us to improve. I'm going to be linking below in the description a free course on how to make your own convolutional neural network. So here's the challenge. Take this course and then come back and try to build your own convolutional neural network to the whale challenge. If you can do that, come back here and comment, I did it. If you want more content like this every week, don't forget to subscribe and leave a like.